Welcome to the EMQX Cloud tutorial. In this session, we will explore how to build a powerful IoT data pipeline by streaming MQTT data directly into Confluent Cloud. Before we dive into the configuration, let's understand why this integration is so valuable. In a modern IoT architecture, EMQX and Confluent Cloud play distinct but complementary roles. Think of EMQX Cloud as the specialized entrance for your devices. It excels at handling millions of concurrent connections, managing unstable networks, and processing lightweight MQTT messages from efficient IoT devices. On the other hand, Confluent Cloud, built on Apache Kafka, is the central nervous system for your data. It shines at high-throughput buffering, stream processing, and distributing data to downstream systems, like databases, analytics engines, or AI models. By bridging these two, you get the best of both worlds. You allow your IoT devices to use the lightweight MQTT protocol without needing to implement complex Kafka clients. Meanwhile, your backend systems receive a reliable, ordered stream of data through Confluent. To make this connection happen, you first need to establish a network path. You have two main options here. The first is public networking. If you are using a basic or standard Confluent cluster, you can enable the NAT gateway in EMQX Cloud. This routes traffic securely over the public internet. The second option is private networking. This is ideal for enterprise scenarios where security is paramount. It keeps all traffic entirely on private IP addresses, offering better security and lower latency. In this video, we will focus on demonstrating the VPC Peering method. To follow along with VPC Peering, you need a dedicated deployment in EMQX Cloud and a dedicated cluster in Confluent Cloud. First, please pay close attention to the region. For the peering connection to work, both clusters must be deployed in the exact same location. Additionally, if you specified 3 CIDR ranges, one for each availability zone, you need to submit a support ticket containing all 3 ranges. Our SRE team will use this information to complete the additional configuration required for your connection. Let's set up the peering connection. First, navigate to the Network Management tab of your Confluent Cloud environment and select the For Dedicated Cluster tab. Choose the specific network where you want to add the connection. Then, under the Ingress Connections tab, click the button to add peering. You will need to input the VPC details from your EMQX deployment, which you can find in the EMQX console under the VPC Peering section. Once you've entered the details in Confluent, return to the Network Overview page and copy the Confluent Cloud VPC ID. Now switch back to EMQX Cloud. Enter that Confluent VPC ID and click Confirm. When the status changes to Running, the secure tunnel is ready. Next, let's configure the connector. Go to the data forwarding page in EMQX Cloud and select Confluent. Since we are using VPC Peering, make sure to use the private endpoint address provided by Confluent for the Bootstrap hosts. If you were using the NAT gateway method, you would use the public endpoint. Enter your API key and secret, click Test to verify, and then save the connector. Now we define how to process the data using the rule engine. Create a new rule to select data from your MQTT topic such as test. You can the SQL area to enrich your data. For instance, you can select the raw payload and automatically add metadata like the client ID and timestamp. This gives your backend teams more context without changing the device code. After testing the SQL, click Next to add the action. First, enter your specific Kafka topic. Please note that dynamic variables are not supported in this field. You must enter the exact topic name. Ensure this topic is already created in Confluent Cloud, otherwise the action will fail. Next, you have the optional Kafka headers to pass in any metadata or context information related to Kafka messages. For the message key and message value, you can enter a pure string or use placeholders like client ID to dynamically pull data from the MQTT message. Finally, you can configure the partition strategy to decide how messages are distributed across partitions and enable compression if you need to optimize bandwidth. For this demo, we'll click Confirm to save the setup. Now let's verify the entire pipeline. First, open MQTT-X to simulate an IoT device. Connect to your deployment and publish a test message to the topic test. Once the message is sent, switch back to the EMQX dashboard. Refresh the rule statistics page. You should see the success counter increment by 1, which confirms EMQX successfully processed the message. You should also be able to see the enriched message in your Confluent Cloud cluster, ready for consumption by your applications. Thank you for watching, and for more detailed guidance, please check out the official EMQX Cloud documentation.